Okay, this is a video tutorial on the Big Ideas Geometry Section 3.2, Parallel Lines and Transversals. Three major learning objectives are I can use properties of parallel lines, I can prove theorems about parallel lines, and I can solve real-life problems. So the four major theorems that involve two parallel lines that are cut by a transversal have to do with pairs of angles that are either going to be congruent or supplementary. So the first set of angles that are created when you have two parallel lines that are cut by a transversal are called corresponding. Remember last time we talked about corresponding angles are the ones that face the same direction or in the same area. So those two will be congruent if your lines are parallel and they're cut by a transversal. Alternate interior angles, remember those are the ones that are inside your parallel lines but on opposite sides of the transversal, then those two are also going to be congruent. Alternate exterior is the same idea as the alternate interior, but instead of being inside your parallel lines, they are on the outside. Those are going to be congruent. And then your consecutive interior angles, the ones that are on the same side of your transversal and inside your parallel lines, those are going to be supplementary. Remember, supplementary means add up to 180. So right here on this diagram, we have two parallel lines. P and Q are parallel. Notice the red arrows right here. Cut by a transversal T, and you have 8 different angles that are being created. Your two different pairs, depending on which theorem you're going to look at first, so let's go back to the corresponding angles. Corresponding angles are the ones that are facing the same direction, so angles 1 and angle 5 are corresponding. If these two lines are parallel, then they're going to be congruent. Another pair would be 2 and 6. Those two are facing the same direction. If these lines are parallel, then those two angles are congruent. Then we've got 3 and 7, same thing. If they're parallel, they're congruent. 4 and 8. So that would be corresponding angles. Alternate interior. We're going to look at the ones that are on the inside of the line. So we're going to ignore 1 and 2. We're going to ignore 7 and 8 because those are exterior. Opposite sides of the transversal would mean that one pair would be 3 and 6. If your lines are parallel, those two angles will be congruent. Same thing looking at angle 4 and angle 5. Those are a pair of alternate interior angles. Now when we look at our alternate exterior, we're going to ignore 5, 6, 3, and 4. Then the alternate exterior angles would be 1 to 8, and then 2 to 7 would be the other pair of alternate exterior angles. Consecutive interior. We're ignoring the exterior because we see the word interior. So consecutive would mean that they are on the same side of the transversal, which would mean 3 and 5 are consecutive interior. Those two are supplementary. That means they add up to 180 degrees. The other pair would be 4 and 6. Since those two are consecutive interior angles, they are supplementary. Okay, so first example, we have the measure of 3 of the numbered angles are 120 degrees. What are those angles that are also 120 degrees? Well, there's a couple different ways you can approach this. First, we're going to look at which one is marked 120, and then figure out possibly the other 3 from there. The other one that's marked 120 is the upper left-hand corner. We could first look at the alternate exterior angle from 120 degrees to number 8, and we remember that alternate exterior angles are congruent, so angle 8 would be 120. Then we could also look at the corresponding angles from 120 to number 5. Notice how they're both in the upper left-hand corner. Or you could also use the fact that 5 and 8 are vertical angles, and you know that vertical angles are congruent. So 5 and 8 are going to be the same, which means that 5 is 120 degrees. And the last one would be to find angle number 4. Angle number 4, you could either use 4 and 5 as alternate interior angles, or you could even use 120 to 4 as vertical angles to get number 4 is equal to 120 degrees. So it's kind of like a domino effect. As soon as you get one of the other angles figured out, you can use multiple different ways to get the rest of the angles figured out. And even though the directions don't ask, there's also ways for you to figure out what 2, 3, 6, and 7 are as well. So your answer would be that 4, 5, and 8 are your other 3 angles. So again, there's a bunch of different ways. Just because right here I'm saying vertical angles are 5 and 8 is your reason, that doesn't have to be your reason. You could have said that 120 and 5 are corresponding angles, and that would also mean congruent. Okay, so we're going to need to find the value of x. We're given that A and B are parallel lines cut by a transversal. We see that that one is marked 115 degrees, and we need to figure out what the value of x is. So the way we're going to approach this, so angle x plus 5 in relation to 115 degrees does not have a relationship, but we do have a relationship between 115 degrees and the angle marked number 4. Those are vertical angles, so we know that the angle marked 4 is 115 degrees. We can use that to then snowball into the x plus 5 angle by saying that they are consecutive interior angles, and we're going to add those two together and set them equal to 180 degrees. And since, again, we now know that angle 4 is 115, we're going to substitute that in. 115 for angle 4. Add your like terms. 115 plus 5 is 120. And then you get rid of the 120 by subtracting to get x equals 60. We don't have to find the value of that angle because the direction's just to say find the value of x. So we are done right there. X equals 60. So you can go back in and check, though, plug in the x into the x, or plug in the 60 into the x, and see if that is supplementary to 115. Well, does that actually work? 60 plus 5 plus 115, yes, it does equal 180. So that's a way you can check and see if your work is correct. All right, find the value of x. This is the exact same type of problem, but you're using different angle relationships to figure out what they are. So we're given that lines C and D are parallel. Angle 1 is next to 136, and then angle 7x plus 9 is way off there on the bottom. So it looks like first we can figure out what angle number 1 is. Number 1 and 136 are next to each other on a straight line, so that means that they are a linear pair. Because remember, linear pair is supplementary, that they add up to 180 degrees. So you can use that information to take away from 180 and get 44 for your angle 1. So now, since C and D are parallel, we're going to use our theorems that we learned earlier about parallel lines, where angle 1 to 7x plus 9 are alternate exterior angles, and you do know that those are congruent. So plug in 44 for your angle 1, and then solve using algebra from there. Subtract 9 on both sides to get 35. Divide by 7 to get x equals 5. And again, the directions just say find x. Doesn't say find that angle value. Sometimes it may say find that angle value, so that you would then have to plug it back in. Again, just because we're going to go ahead and check and see if we did it correct, we are going to plug that back in and see that 7 times 5 plus 9 does equal 44. Okay, so kind of working backwards now, proving that if two parallel lines are cut by a transversal, we're going to go ahead and first draw a diagram with two parallel lines. You can label them whatever you want. Line T is cutting lines P and Q. Label your pairs of alternate interior angles. You could use X and Y. You can use 1 and 2. It doesn't matter. So we're looking for an angle that is related to both angles 1 and 2. Notice that one angle is vertical angle with 2 and a corresponding angle with 1. And that's going to be that purple one that gets highlighted, where it is vertical to number 2, but corresponding to number 1 because it's in the bottom left-hand corner. So that would be your angle 3. So before you can write a proof, make sure we are knowing what our given is and what the prove statement is for our diagram. So we're given that line P is parallel to Q. We have to prove that angle 1 is congruent to angle 2. So again, two column proof, statements on the left, reasons on the right. Always start with your given as the first statement and reason. We are given that line P is parallel to line Q. Then we are using the corresponding angles theorem, which we were already given, to prove that angles 1 is congruent to angle 3. Then using vertical angle theorem, which we learned back in chapter 2, that 3 is congruent to 2. So then based on the transitive property of congruence, if one thing is congruent to another, then you can just say that those two things are congruent. So angle 1 is congruent to angle 2. Okay, when sunlight enters a drop of rain, this is our real life problem. Different colors of the light leave the drop at different angles. So this is what the process is used to make a rainbow. For violet light, the angle has to be 40 degrees. What is the measure of angle 1 and how do you know? Well, based on the diagram, the yellow lines are marked as parallel. Those are the sun's rays. They're going to be parallel the direction that they leave the sun, whether it's from the top of your head or up to the rainbow. So angles 1 and 2 are considered alternate interior angles. And since we know what angle 2 is, we know that angle 1 is also congruent to that. So angle 1 is also going to be 40 degrees. And your reason would be the definition of congruent angles by alternate interior angle theorem. All right, so again, it's kind of a domino effect. Once you get one of them figured out, the rest will be pretty easy. You have a 50-50 shot of congruent or supplementary. More often than not, they're going to be congruent. But usually pictures can help you lead to believe that an angle could be less than 180 or greater than 180.